Good afternoon or good morning, depending on from where you are joining. And welcome to this 2024 International Online Seminar on the title, Bamboo in Africa, Pathways to Sustainable Construction and Development. My name is Rattan. I work as the Regional Director for Central Africa of the International Bamboo and Rattan Organization. And it's my privilege to co-moderate today's session together with Professor Denamo Adisi, who is an Associate Professor of the University of Addis Ababa. As we gather here virtually, we are united by a shared vision to explore innovative solutions for Africa's sustainable growth, solutions that not only address continental environmental challenges, but also promote economic development and social well-being. As you may know, bamboo is often referred to as a green gold. It is a versatile, fast-growing, and eco-friendly material with incredible potential for African construction industry. In a continent that is facing both rapid urbanization and significant environmental challenges, bamboo offers a sustainable alternative to conventional building material, supporting affordable housing, job creation, and eco-friendly infrastructure development. Today, we will hear from three renowned speakers who would share their insight on how bamboo can be integrated into construction practices across Africa, enhancing both environmental and sustainability community development. From carbon sequestration to affordable housing solution, bamboo presents a unique opportunity to Africa to lead in sustainable innovation. The seminar promises to be an exciting, insightful journey as we explore the pathways that can unlock bamboo's full potential for Africa's construction future. We encourage you to engage, ask questions, and to be part of this important conversation. So our program today is a very simple one. We are going to have three wonderful speakers, and we are going to have a closing remark. I'll be moderating the first part of the session, and my colleague, Professor Denamo, is going to moderate the second part of the session. So the first part of the session would be to introduce the speakers to you and their presentation, and from there, my co-moderator will take over. So it is my privilege to introduce to you our first speaker today, who is Professor Emmanuel Kubi. He is an associate professor in the Department of Civil Engineering at the Apia-Menka University of Skills Training and Entrepreneurship Development of Ghana, where he also serves as the Dean of both Faculty of Technical Education and Faculty of Engineering and Technology. He holds a bachelor degree and a PhD in Civil Engineering from Kwame Nkrumah University of Science and Technology in Kumasi. With over a decade of experience, Professor Apia Kubi has worked as a research scientist at the Forestry Research Institute of Ghana and has completed international research stays at the Georg Austin University of Göttingen in Germany and the Bern University of Applied Science in Switzerland. He is a professional engineer and a member of the Ghana Institute of Engineering. Professor Kubi specializes in both construction of wood industry with expertise in timber and wood structures. He is an active participant of the ISO Technical Committee 165 on timber structure and 296 on bamboo, and contribute to INBAR two task forces, the Task Force on Bamboo Construction and the Rattan Development. His experience and global collaboration makes him a leading expert in sustainable engineering practices. Today, Professor Kubi will talk on the topic, Building Carbon Negative and Ecological Smart Cities, the Bamboo Eco-City concept in Ghana. Professor Kubi, thanks for gracing us of your presence. The floor is yours for your presentation.
Thank you very much, Rainy, for the wonderful compliment, the introduction. For once, I was thinking, oh, is this all for me? Thank you, I'm grateful. So I want to share my screen. I hope that you can see my screen.
Yes, we can see your screen.
Right.
Yes, we do.
That's great. So good afternoon from Ghana to everyone from every part of the world. I want to share with you about this concept of building carbon negative and ecological smart cities. And we have an example here in Ghana I want to share with the whole world. We call it the Bamboo Eco-City concept. By way of introduction, I want to share with us some of the statistics when they talk about climate change and population rise and its consequences. Currently, it's estimated that between 2015 to 2050, the world population will increase by 32% from the 7.2 billion all the way to 9.7 billion inhabitants. And the urban population will increase by 63% to about 6.3 billion. And these current estimates says that until 2030, over 60% of the world population will live in the cities, and the significant growth will be in Africa, Asia, and Latin America. So for us in Africa, our population rise will continue, and the numbers are going to escalate. There's therefore urgent need for sustainable practices. The rapid growth of population and this urbanization is also bringing along with challenges to our environment, especially in the urban communities. And we're talking about cities. We're talking of energy issues, water issues, pollution, waste disposal, disposing of waste safely. The housing deficit is alarming. So there are a lot of slums splitting up in most of these cities, urban areas. And of course, inadequacy in infrastructure to cope with this increasing flow of citizens from rural areas to the cities in hope for better life is something that's happening also in Africa that we have to take a look at. Now, although these cities occupy only about 3% of the planet's surface, the cities consume 60 to 80% of the total generated energy and are responsible for 70% of the carbon emissions in the world. And so to date, climate change is involving the whole planet, and we are all talking about it. And it's upsetting national economies, communities, and countries. We see that the sea levels are rising, weather events are becoming more extreme, and greenhouse gas emissions are currently reaching the highest levels in history. These are the realities we find ourselves in. We see flooding all over. In fact, the World Health Organization also predicts the impact of climate change on human health. It's in four prongs. We have the rising temperatures effect causing severe weather, injuries, fatalities to mental health impacts, as well as the extreme heat causing heat-related illness and death, cardiovascular disease, and so on. If you look at increasing CO2 levels, it's about environmental degradation. It's also about water and food supply impacts. And then the rising sea levels is causing water quality impacts as well, with lots of attendant diseases, cholera, and then so forth. You also have more extreme weather. You're talking about the air pollution also leading to certain illnesses, and then increasing allergies as well as other diseases. All these are coming about as a result of the emissions of carbon. And one of the sectors that emits carbon is the conventional construction materials used and the effects on this climate change. The building construction emissions is estimated that about 7.9 million tons of carbon dioxide equivalent is released from the building construction. And that one alone, construction processes, is about 11%. The materials we use for construction, especially concrete and other cement-based products, constitutes about 32% of these 7.9 million tons carbon dioxide emissions. That's very alarming. We're talking about steel reinforcement, also constituting a huge percentage. The materials and transport and so many other things constitute all these percentage of the emissions. And that has given us the effects I've talked about earlier. So this brings us to having to rethink about the materials we use for construction in the cities we are putting up. So to address these challenges, the concept of carbon negative and ecological smart cities has emerged as a beacon of hope. Some developments or some cities have zero carbon, but it is possible to also achieve a carbon negative ecological smart city. What are these cities? These cities prioritize sustainability, innovation, and technology. They use these three pillars to create urban environment that only mitigate the carbon footprint, but actively contribute to environmental restoration and preservation. So it's a balance. And you could balance it to the point where the preservation, the absorption or sequestration of carbon could surpass the emissions you deliver to cause these climate change issues. And that means you have a carbon negative city. There are principles that govern these carbon negative ecological smart cities. Like I said earlier, sustainable urban planning and design is a key principle. Utilizing renewable materials that have low impact on the environment. So low impact construction techniques or methods are utilized in the construction process. And then you also use renewable construction materials. You also ensure that renewable energy integration is practiced. The use of solar, wind power generation, geothermal energy systems, cogeneration are all utilized in these cities. We also talk about resource efficiency and waste management, making sure that there's recycling, upcycling initiatives, there's composting, and also bioenergy use instead of the traditional energy sources. Biodiversity preservation is also important. Keeping green spaces and urban forests, as well as habitat restorations, are all important principles of the carbon negative ecological smart cities. Again, technologies and innovations of the carbon negative and ecological smart cities involve, again, the green building materials and techniques, the use of Internet of Things and AI applications for energy management, smart grid systems, automation systems. You don't waste resources in these cities. Transportation solutions, provision of public transit by systems so that you don't pollute the environment or the city with burning of fuel. Then urban agriculture, and as I said earlier, green spaces include having rooftop gardens, vertical farms, community gardens, and some fruit forests within the city. These are the innovations and technologies. So the smart cities have some key characteristics summarized here on this slide. You find out that a smart city has a smart environment, smart mobility, smart utilities, that's in the energy efficiency, smart infrastructure. In fact, the government is smart. E-government services and all those play a role, as we call it smart living, and then smart education as well. Then the citizens become also smart. So these are, in summary, what we talk as characteristics of these smart cities. So one exemplary project that embodies these principles is the Bamboo Eco City in Ghana. It is situated at the intersection of tradition and innovation, and it redefines urban development by harnessing the sustainable properties of carefully selected, locally sourced materials. And I'll talk later more about these materials going to use for this city. You can see this is the sketch overview of the city. It sits over a 260-acre land in the southern part of Ghana. It's closer to the coast. And here we want to appreciate Autodesk for the support through one of the best architects in the world who have supported us in developing and designing this ecological smart city. Their names are there. You can see, so we appreciate their support. These are one of the finest architects in the world who are all part of this project. Now, on this slide, you find the land area for this project. And incidentally, this land area, the coverage looks just like the African map, and we're so proud of it. In total, we have an area of 262 acres of land for this city development. And by way of sketch, there are sections where you have all people, of manner, the sort of people, different classes who can live or inhabit in this city. There are industries, educational centers, recreational centers, commercial centers, ecotourism centers, all available within this sketch. This also gives you an overview of the development of the structures in the city with the road networks as well as the buildings with the vertical farms at the rooftop of these structures. A much closer look at some of the housing within the city. Now, the materials being used for the construction of this city, the principal material, like I mentioned, a sustainable material, which is renewable, here is bamboo. And we're also using clay, as in laterite, which is readily available in the communities where this city has been sited. We're also using lime instead of cement as a stabilizer. And then, more important, biochar and some pozzolans. I will share briefly these materials for us to have a look at them. When we talk about the bamboo and the lime we have identified in Ghana for this project, we are having lime laterite bricks, and in some cases it's clay. And the compressive strength of this material that we've developed is ranging between 5.5 to 6.5 Newton per millimeter square in terms of compressive strength of these bricks. For the bamboo, we are talking of tensile strength of Bambusa vulgaris, which is predominantly found in Ghana. We're using 205 Newton per millimeter square with a compressive strength of 50 Newton per millimeter square. These properties have been determined with a period of time research conducted both on the bamboo and the lime laterite or clay bricks we're using for these constructions. The biochar is also an interesting part of this development. We're making biochar using bamboo, which is heated at very high temperatures through the pyrolysis process. And it has these unique properties with a high specific surface area, which is 300 square meter per gram, and very efficient medium for storing moisture. It has a lot of pores that trap large quantities of practically mobile air, and it has these numerous advantages we've discovered and we're using for this project. To give you more insight, it's insulating, it improves the air quality, and it's able to soak up moisture. So rooms built with this biochar in the mix are always having this air quality because you won't have much humidity build up because of the high temperatures in our sub-region, the tropics. The biochar is doing this and is sinking this carbon in the building. And in fact, every ton of biochar used for this construction is going to prevent the emission of a ton of carbon dioxide entering into the atmosphere. The city's roads has been designed to incorporate this biochar in the modified asphalt mix, which makes it more renewable for the city's construction. For the clay and the lime, they are natural deposits of clay, and there is a company here in Ghana who is also producing this lime for us. Lime has that unique properties of making the buildings cooler in these warm climates, and therefore you don't need high energy usage in terms of trying to cool the buildings that we have in the eco-city. prototype brick producing machine and the bricks that were produced to try on the land soil investigations has been done. You can see in the pictures. And even from the tests and prototypes, new designs of the machine for industrial purposes to produce huge volumes of these bricks have been procured for large-scale production of these bricks. The bricks, as you saw earlier, are hollow type to incorporate the raw bamboo combs from having to be inserted in them for this tensile capacity, because the blocks cannot absorb this tensile strength, and that is where the bamboo does its magic of this high tensile strength property. So the city is a major solution to the housing deficit. It's also going to create employment and help mitigate climate change. It has residential apartments, commercial, industrial, tourism buildings that will be there. People can come for ecotourism in the city as well. All the materials are locally sourced, and we have estimated that the cost of this housing will be reduced by 50% compared to the conventional housing that we have in the city or other real estate. So, as a carbon negative and ecological smart city, it prioritizes sustainability, the innovation, and environmental stewardship we talked about earlier as key principles of the eco cities. It's going to negate all the carbon footprints while fostering the biodiversity and enhancing the well-being of its inhabitants. Now, there's going to be sequestration of the carbon by use of these materials I've talked about. You're also going to make sure that the city prioritizes the preservation and restoration of the natural ecosystem. The inhabitants who are living around these communities are being engaged, and they will not be moved. They will have access to this city, and we want to keep the natural environment, because in a rural setting, not in the current urban setting. The use of smart technologies will be engaged to make sure there's efficiency of use of these utilities and resources like water. Then the community engagement I talk about, fostering collaboration between the government agencies and the businesses that will be there within the enclave. We are also utilizing bamboo and rattan products, handicrafts, household utensils, even beds are being constructed from bamboo and rattan products. These are some of the artifacts that are proposed for even income generation within the rural economic setting for a boom in the economy of the localities. This also hasn't come without challenges. There are issues of policy and regulatory hurdles, because if you want to utilize pure locally sourced materials, it has to be accepted. We have dealt with a lot of government agencies, and they're all collaborating with us. In fact, the whole Regional Coordinating Council, Cape Coast Development Commission, are very much involved in this project, and that was a big hurdle. Now, advocating for sustainable development policies is also something that we're looking at. But of course, because the incentives for green building practices, if that could be a policy, it will encourage and support the setup of cities like this one. There's also the issue of standardization of bamboo composite housing designs. We have a lot of standards for conventional housing, use of concrete, use of steel, use of glass, and all those, but integrating bamboo and lime bricks is something new, incorporating biochar in them, and therefore calls for more standardization. And you have to go through this process as well. Another challenge is the financial consideration and investment. Though we have few investors who are investing into the production of the bamboo as well as the lime bricks, there are more investors needed in the other aspects to make it more sustainable. There are investors whose practices are not sustainable, and therefore we do not encourage them. So getting people who are interested in green building practices is one of the challenges that the city is also facing. And of course, community engagement and the participation. A lot of education had to go on for people to accept that you don't need to build in cement or concrete blocks. You can build using bamboo and a local laterite or bricks to make the city smart. And so empowering local communities through capacity building is also very key for us. I want to thank you very much for your attention and time for this Smart Cities presentation. We are available for more inquiries as well as more information if there are questions. Thank you.
Thank you very much, Professor Kubi, for this wonderful presentation and great innovation. Congratulations for this project. It was good to know that conventional construction accounts for 11% of our greenhouse gas emission, with an estimate of 7.9 million tons of carbon dioxide equivalent. So such a project is really welcomed. You talked about ecological smart cities, trying to highlight what are the characteristics of the smart city, including sustainable design of the cities, the use of renewable energy, the resource efficiency in terms of use, recycle, and reuse. You talked about biodiversity dimension in the smart cities, and all these, we saw that they are key features in this smart city that you're trying to propose in Ghana. So I think most of our participants have expressed interest in this, and please just jot down your questions into the chat box, and my colleague Demanu is going to address these questions with the speakers. So once more, we want to thank Professor Appiah Kubi for this excellent presentation, and we are going to move to the second speaker today, which is Mrs. Sylvia Essenti. She's an architect with a passion for alternative building materials and environmental conservation. She holds an undergraduate degree in architecture and a postgraduate degree in environmental policy. With over 14 years of professional experience, Sylvia has worked in both private and public sector, and she currently serves at the National Building Authority in Kenya. In addition to her work in the public sector, Sylvia has experience as a lecturer at the Technical University of Kenya. She is also the founder of the Mianzi Design, a company focused on researching and promoting innovative applications for bamboo in construction. Her work aims to advance the use of bamboo as a sustainable building material in the Kenyan market, aligning with her commitment to environmental sustainability. Through her extensive career and research, Sylvia is an advocate for greener building practices and continues to strive change in the construction industry. We are very happy to have Sylvia today, and she's going to speak under the topic, Emerging Trends and Opportunities in Bamboo Construction in Kenya. Sylvia, the floor is yours.
Thank you very much. Please confirm that you can see my presentation and that
we can see your presentation, but we need the full screen mode.
Okay. Yeah, is that okay?
It's a bit of black. Beautiful. Over to you.
All right. Thank you so much. Greetings, everybody. As you've heard, my name is Sylvia. So today I'm going to present about emerging trends and opportunities on bamboo construction in Kenya. My presentation is divided into 5 sections. I'm just going to look at the country at a glance. I'm going to also look at the local use of bamboo in construction. Part 3, emerging opportunities for use of bamboo in construction in Kenya. And then the fourth part is going to be barriers to the use of bamboo for construction in Kenya, and then what the future looks like. So we all know we are speaking about Africa, and Kenya is in the East African region. The country has, in terms of the governance structure, is governed by the national government at the apex, and we have 47 county governments under it. Each of these units has a chance or to come up with policy regarding bamboo. So to looking at the historical or the coverage of bamboo in the country, we have one native species, the Oldinia alpina, formerly Eugenia alpina, found in what we normally call our water towers. We had trials being done bamboo species, and so successfully we
I'm very sorry, we've just lost Sylvia. I'm pretty sure it should be a technical issue due to internet connectivity. So what I would suggest is that we come back on her later on. So we are going to quickly shift to our third speaker today. And then from Paulino, we are going to move back to Sylvia. Hopefully by then, her internet connectivity would be stable. So Paulino, I'm going to introduce you and give you the floor for your presentation. So Paulino Batao is an environmental expert with over 12 years of experience in using bamboo for sustainable development. He holds a master's degree in environmental studies and sustainability from Lisbon University and currently works at the Rattan University of Applied Science in Frankfurt. Paulino has led several impactful projects, including Bamboo Park, Bamboo for Biochar and Charcoal, and Bamboo to Replace Mangrove, focusing on bamboo's role in land restoration, carbon sequestration, and environmental conservation. As a project manager at the World Wheat EV, he promotes bamboo as a sustainable alternative to traditional material, fostering ecological resilience, and community-driven development. His work also includes developing curricula for bamboo research, advancing its socioeconomic benefits, and positioning bamboo as a key solution to global environmental challenges. Paulino is a recognized leader in the global bamboo movement, contributing to both practical applications and educational initiatives to support sustainable practices worldwide. Today, Paulino is going to entertain us under the topic environmental conservation and climate reliance. Paulino, the floor is yours.
Thank you so much for the great introduction. Good afternoon from Frankfurt, everyone. Yes, my name is Paulino Batao, as has been mentioned before. And well, the introduction was great. So the little piece of paper that I had to introduce myself, I'm probably not gonna use it anymore. So I'll share my screen. Today I will not dive into the construction, although can you see my screen?
It's coming. It's loading. 1 second. Okay, we can see the screen.
Okay,
but
perfect.
We need the presentation mode. Yes, full screen.
Yeah, it's taking some time to be in a full screen. Right now, is it a full screen?
Yes. Over to you. Thank you very much.
Perfect. Yeah, as I was saying, like I'm teaching at university, INBAR University, in sustainable construction. But today I will not talk about the construction itself. I'm more diving into some projects that we focus in Mozambique. So that's why I will talk about the bamboo as a nature-based solution for environmental protection and biodiversity improvement. Well, the content today, it's probably the understanding the problem, which is deforestation in the Mozambican case. That's why we're going to have like Mozambique as a case study, and adapting to the new normal, bamboo strategic solution for climate and biodiversity, bamboo social and environmental benefits, and Asamba's ongoing project. Asamba is one of the organizations which I'm co-founder in Mozambique. It's a Bamboo Friends Association, which links to another social enterprise that I'm also co-founder here in Germany, to make the link between Europe and Africa. Well, understanding the problem. Deforestation, that's the biggest problem in case of Mozambique and all over the world. That's probably it's known, it's you all. And we have the one of the biggest problems in Mozambique or in all the entire world is the deforestation, and this is connected to the more CO2 emission to the atmosphere, then turns fertile lands into deserts and causes the soil to wash away and hold less water because of less trees on the lands, right? So I'll jump to the case study in Mozambique and why do I say that deforestation is a challenge in Mozambique? Because, well, you can see like Mozambique, it's mainly lost almost the size of Germany since 2008 to nowadays. And the last report from the Agriculture Department reports that it's losing plus minus 265 hectares of its forests. So that's a huge number, and the cause of that, it's mainly for the illegal exploitation of the timber, charcoal production, firewoods, farming, and construction material. This is okay. I'm a little bit stuck here. This is not moving. All right. Hold on. It came to the next slide.
No, Paulino, we are still on the slide on the main causes of deforestation. Now we're on the next slide. Heavy rainfall.
Great. Okay, great. Yes, in one of the causes of deforestation in Mozambique is exactly the heavy rainfall and the cyclones that we get almost every year. For the last 4 to 5 years, Mozambique was affected by almost five cyclones, which decimated a lot of housings, and like thousands of hectares of land was being washed away. Thousands of hectares of crops also being washed. So why I'm bringing the cyclone as one of the main problem in Mozambique is because, first of all, the deforestation is one of the reason that the land cannot hold the water and cannot absorb the water. And with less trees, we're always gonna face this problem. The cyclone's gonna be there, that's for sure. But with less trees, the effect's gonna be even worse. Here we go. So I also would like to talk about adapting to the new normal. When I'm talking about the new normal, is exactly the cyclones that has been affected Mozambique. And we have to survive with this new normal, because this is going to get worse and worse. It's not getting better anytime soon. And the effects of climate change to be mitigated and adapted, as a Dr. Emmanuel already said or mentioned, like reforestation initiative should be one of the main strategy, building adaptability and resiliency, utilizing technology and innovation solution, as the Eco Bamboo City presented by my colleague. This is a great project you have there, by the way. And yes, so bamboo as a strategic solution for the climate and the biodiversity. Why do I choose this?
Sorry, from our side, your slide has not changed from the heavy rainfall slide. I don't know if you are talking on different slides now.
I think I'm talking a different slide. I'm in
you are stuck at slide number 7.
Okay, give me a second.
Yeah,
can you see the strategic solution for climate change and biodiversity?
From my side,
probably it's good if he takes out this slide and then share it again. Probably that would work.
Yeah, so Paulino, we suggest you stop sharing and you reshare back.
Okay, let me do that then.
Thank you.
What about now? Can you see the screen?
Yeah, now we can see the screen. So we're stuck at slide number 7.
Oh dear. So we were number 7. Is showing now the right?
Yes, now it's number 7. Over to you.
Perfect. Yes, I was talking about the heavy rainfall and the flooding that are caused by the tropical cyclones, which are the consequences of the tree cover loss in Mozambique. And I was just explaining that Mozambique lately has been affected by several cyclones, which is leading to the loss of lives, great amount of fertile soil and crops. Is the reason that we define like a reforestation or bamboo one of the solutions to mitigate these problems. We changed the slide now, so just to confirm. Adapting to the new.
Yeah, adapting to new normal. Yes.
Okay, perfect. Now. Okay, great. Adapting to the new normal. What I mean by new normal, the new normal is exactly this constant cyclones and floodings and drought that we have almost every year and then. So this is not going to change. This is coming to stay like that. That's why we need to build resilient communities, and to build resilient communities, we need to adopt some strategies for that. And well, the effects of climate change can be mitigated by adapting those the strategy that I was saying, and the reforestation is one of the main initiatives that we have in Mozambique. Besides utilizing the technology and innovative solutions, and I was congratulating my colleague of the project in Ghana. That's just an amazing project, and we wish that we can replicate that to other places in Africa and in diaspora. Well, bamboo as a strategic solution for climate and the biodiversity. Why do we choose bamboo? Probably I'll be repeating myself here, but bamboo is one of the fastest and resilient growing plant on earth. I think all of us know that. And I can confirm that because I'm planting bamboo, I'm cultivating and manage bamboo for almost 12 years. On my bamboo farm tests, I have 12 12 different species. All of them grow differently. But yes, I can say that it's true that grows fast. Although, well, I have some recorded here, like recorded that Guadua grows almost 21 centimeters per day. This is really depends on the environment and so many other factors, the species and so on and so forth. I never witnessed such a fast growth, but I witnessed like the growth of bamboo here in Germany as well in Mozambique, because I do have a plantation. And well, it thrives well in a tropical and subtropical climates, and we like to be living in the tropical and subtropical climates, adapt to most of the soils, poor soils without nutrients, and is versatile of thousand application. And one of the most important facts about the bamboo is withstand many cuts before reaching the end of the life cycle. What means if you have a bamboo that the life cycle is 40 years, from the 50th year onward, when the bamboo is mature, you can harvest almost every year without replanting. This is a big advantage about bamboo if we compare it to other trees. But we have to break some myths here. In Europe, bamboo doesn't have a good image because it's invasive. And in Africa, bamboo is known as a man's poorest timber because, well, we just wanted to build as a Western. But if we have projects like the Ghana city, it's amazing. I think people the communities in Africa could definitely go for it. So it is important that we have to raise awareness to the people that yes, it's some truth that the running bamboo is invasive, but it's invasive if it's not managed, which can be managed. And in Africa, it's good for us. We don't have, at least in a tropical climate like Mozambique, the bamboo, the running bamboo doesn't grow there. We just have a clumping bamboo, so we don't worry about the invasiveness, but we worry of the status, rising awareness to the local community that bamboo could be a really good source of building material, charcoal, and so many other applications. So it's important to raise this awareness to the people that yes, there's this advantage of being invasive and bad image, but this we can turn around. So I also would like to talk about the social and environmental benefits. So due to its rhizomes, systems, foliage, resistant and flexibility columns, bamboo has a positive impact on both socioeconomic and environmental aspects. You have two pictures there. On your left is the last building at Rattan University and summer school that we built. Imagine if you have that if you build such a nice building in Africa, probably people could change their mind and try to build with bamboo. And on your right, for the environmental aspect, it just show how the complex root system of bamboo. Then on the next slide, I'll explain you why I have these two pictures, right? Here we go. Regarding the socioeconomic, it boosts jobs, elevates local economy, rural development, and the community can mitigate the immigration to the cities. So if you create the conditions in the local communities, planting bamboo and explore as maximum as possible its value chain, the local community or the rural community will not need to go to the cities. They will stay in the cities. On your left side, we have some experiments. We're doing some briquettes. This is a bamboo powder. And in your right, you have some bamboo, which means if we have like a good bamboo, good stock, the local community can sell and they can improve their lives. Regarding the environmental aspects, bamboo serves as an effective windbreak, control floods and erosion, sequestrate significant amount of CO2, as we've seen in so many presentations about the sequestration of CO2, and restore degraded lands. That picture that I show you the previous slide, it has this complex rhizome and root system of bamboo, which holds great amount of soil. I do some studies and research, not that scientific, but because I love bamboo so much and I want to understand, I want to get out of the theoretical part and go to the practical. So that's why I do this. So both of these pictures on your left, the one on the left and the one in the middle, are here in Frankfurt in my garden. And the middle picture shows that bamboo can filter so much water and hold soil at the same time. And on your right side, bamboo is just leading the way of the river. So what means is really good to mitigate the erosion. It's just brought these 3 pictures to show how exactly bamboo is helping in mitigating erosion and probably restoring degraded lands. Then I would like to show a video, if it is still time, about the projects that we have in Mozambique by ASAMBA. ASAMBA is the organization, a non-profit organization that I mentioned before, which stands for Bamboo Friends Association. Well, we have the first, before we go to the video, like the Matutin Bamboo Park. It's a hub for rehabilitation, education, and recreation. Our plan here is to restore 16 hectares of old sand mines into Bamboo Park for showcase sustainability. We have an agreement, or we're partnering with Maputo Conservation Area. That's like Matutin, the southeast of Maputo or Mozambique. And we have these lands that we can play on it. It's our playground. So we wanted to plant 4,000 bamboo, which we are in the process of multiplicate them, and 3,000 endemic trees. Related to this project, we also have 1,000 hectares of degraded lands that we are planning to rehabilitate with bamboo and endemic trees. We don't only plant bamboo, we do endemic trees, we do the mixture, because bamboo is only to replace those trees, endemic trees that take long time to grow. Instead of using these trees after some time, we use bamboo for its characteristics, physical and mechanical characteristics. So this is also some details of what the park would look like. I was saying the park, it will be our playground, because there's a lot of land to play with. Well, it's not like a 200 hectares of the Ghana city, the eco city, but we start small. We do like some restaurants, some shade areas, a playground, picnic areas, and pathways, mostly using bamboo and other sustainable construction material that can be used for this park. So as you see, this like on the middle picture, it's like an open hand. So when we saw those are water. In blue is water. Unfortunately, they cannot maximize this, but this is just an example of what we are doing in terms of rehabilitating degraded land using bamboo. And also we have a pilot project, which is like a bamboo agroforestry for salt-affected soil. We've been funded with some Dutch or Holland's, Netherlands organization to solve or to improve soil salinity problems. And some bamboo species are good for soil salinity. They can stand in the soil salinity. So we're going to use some 3 or 4 species for that to improve the soil salinity. So that's a great opportunity for us to research on bamboo and soil salinity. We also have it's called another project. It's called Ben Blue Forest. Is in a partnership with Blue Forest. Is one of the biggest, if not the biggest, mangrove reforestation in southern or central Mozambique. The project is aiming to rehabilitate and conserve about 5,000 plus hectares of mangrove. So we thought of bringing bamboo into that so we can replace the use of mangrove with bamboo and have the mangrove growing. We did a feasibility study, a successful feasibility study. Now we're starting to looking into a nursery to produce enough amount of seedlings, so to plant on this interior from this region where this mega project of mangrove will happen. Yes, the call for action. As I say in this section, I would like to show you a video. If I have time, it's just 3 minutes video that almost summarizes what I've been saying here. Let me know
please,
if it plays.
go ahead with the video. If it's 3 minutes, it's okay.
Yeah. Can you see the video?
The screen is dark. The video is not playing, at least from my end.
Sorry, 1 second.
Yeah.
Hold on.
Same here. Same here. Yeah.
Can you see now?
Now I see a picture of a devastated land, but it's a still picture. It's not a video playing.
Okay,
Now I see a group of happy folks. Mm.
Okay, well, here now.
Not playing. Maybe if you have the picture, it's playing now, but
It's coming up. It looks like it's coming up, but it's quite slow.
Yeah, the slag is a bit important. If you have the video detached to the presentation, it might be.
Yeah, maybe I'll stop the video because if it's too slow, maybe it's too heavy. Hello?
Yeah.
Can you hear me?
Yeah. Yeah. So maybe you stop the video and you share it so that we can upload it with the presentation. So that
Yes,
people
I
can...
have shared the video with you. So if you could play by your side, it will be great.
Do we have the permission to upload it?
Yes, please.
Thank you very much. So
thank you. I'm sorry for the connection. That was what I would like to share with you. And this is a part of our team in Mozambique. For any question, please feel free to drop in the inbox. And if you can play the video, I would appreciate, because it shows what we're doing.
No, it's okay, Pauline. I really want. I think the technical team in Beijing, if they can play the video. Chinho, is that possible?
Maybe. Do you have the video document itself? So maybe you can just play the video directly. So
Pauline, what my colleague is suggesting is that you open the video file and you reshare your screen, but not playing it from the attached PPT.
Okay, yes. All right, great, understood. Let me see if I can do that quickly. Otherwise, it's okay. It's not a big deal.
Okay. And to the rest of the audience, please, if you have questions about the presentation, kindly drop your question in the chat box. My colleague would come back on all those questions after our third presentation. So please kindly drop your question in the chat box. It would be good if you before your question, tell your name and your country so that we know from where the questions are coming from. So Paulino, is that possible?
I think it's better if we proceed, because here is also a little bit slow.
Okay, okay.
Yeah.
Very sorry for that, but all the same, thank you very much for the presentation.
Thank you very much for your time, and thank you everyone for listening to what we doing.
Okay, so I think we are going to come back to you with questions. So please bear with us, and we are going to move to our third speaker today, Sylvia. Sylvia was already on when we had a technical breakdown. We lost her, likely due to internet connectivity. But Sylvia, can you hear us?
Yeah, I can hear you. I can hear you, although there's a bit of disturbance from my end, but I can hear you. So,
are you good now to share your screen and come back on your presentation?
yes.
Please. So please kindly share your screen and over to you as you've already been introduced.
All right. Question, at what point did I lose you, or did you lose me? Because I can just continue from where I had.
I will advise if you can start all over, I think you'll be better.
Yeah. All right. Okay.
Yeah. Thank you. Thank you.
So my presentation is on emerging trends and opportunities on bamboo construction in Kenya. My name is Sylvia. I had already been introduced. I'm an architect. I have structured my presentation along those 5 areas, looking at Kenya at a glance. Emerging opportunities for use of bamboo in construction in Kenya, barriers to the use of bamboo, and then the future. So very quickly, I will just look at, we all know this is an African, we're looking at Africa, bamboo in the African continent. So we're in the East African region. The country is divided into 47 counties with, at the apex, the national government. The reason I'm mentioning this is because each of these governance units have a chance to direct the bamboo policy discussion within the governance unit. So in Kenya, the oldest or the only native species we have is called the highland bamboo, also known as Oldinia alpina or Eugenia alpina. It is found in the mountains, about 2,000 meters high. The Aberdares ranges, the Mau Forest, Mount Kenya, Mount Cherangani. And additionally, we have had trials being done with other bamboo species. And we have about 10 other species that have been introduced to the country. They have responded successfully in different ecological zones. So gradually, we have had a drop in the area under bamboo. Initially, the area under bamboo was 300,000 hectares. We have this has reduced by almost 2/3 to 100,000 hectares. And the country has a total resource area of 133,273 hectares of area under bamboo. So when you look at the analysis, the situational analysis, we have a rapid population growth. We are currently at around 50 million. This is projected to be at around 80 million by the year 2050. So we have pressure on our agricultural land, which is also very limited compared to the arid land. Majority of the Kenyan land is found in the arid and semi-arid regions. So about 20% of our land is arable. And of course, now there's pressure on that for growth for food and settlement. The forest sector in Kenya contributes to 3.6% of the GDP. This is according to the UN. And the sector directly employs 650,000 Kenyans. 50,000 is directly and 600,000 is indirectly. So directly, we're talking about things like maybe propagation of trees, lumbering and the like. And then 600,000 are now the jobs that use timber, but not very directly, maybe like things like carpentry. So the forest sector remains largely underdeveloped, but it has great potential. It has great potential for timber lumbering and processing. And we also need to, it is projected, we need to get to a place where we can actually do commercial forestry for us to develop green. And Kenya has committed to using sustainably grown wood in the construction industry, according to the COP28. The national plan is to increase the forest cover to 750,000 hectares. There is no mention of how much of this is going to be is going to bamboo, but largely this is where we are. The country depends on wood for a lot of for a diverse number of uses. We depend on wood for timber, poles. We use poles in construction. We have wood fuel such as firewood and charcoal too. The construction industry consumes directly from the timber. So of course, timber is used to make things like doors, door frames, panels, cabinets, wardrobes. And then the poles are used to support majorly when you're you're casting slabs. This is what is used to support the formwork. And sometimes these are also used for fencing. But the downside of this is that then we harvest very young trees that could have grown into, bigger trees that could give us better benefits as timber. So according to KEFRI, we have a deficit of, according to KEFRI, Kenya Forestry Research Institute, Kenya has an annual deficit of timber of about 10.3 million cubic meters. So the demand is 41.7 cubic meters, and the supply is 31.4 cubic meters. The UNDP reports that we have a per capita demand of 1 cubic meter. The deficit in construction is as outlined in the table. So in total, the table, we have a deficit, we have a demand of 7.3 million against a supply of 5.2. The deficit comes to 2.1. And for the poles, we have a demand of 3.2 million cubic meters against a supply of 1.4 with a deficit of 1.6 cubic meters. So in total, we have a deficit of 3.7 million cubic meters for both timber and poles. When you look at the existing legal framework, we have the Kenya Constitution of 2010, which is the supreme law upon which we are guided. It delineates, or it gives us the right to a clean environment, a clean and healthy environment. It also prescribes a 10% minimum tree cover, and also environmental and biodiversity protection as a right. And then we have the bamboo policy of 2022, which details bamboo resource availability, and it details the acreage that we have, the species available, and also identifies the gaps in the industry and the approaches of bridging them. We have the National Building Code of 2024. This is a government document. We have been having, or rather we have an older version of the building code, which was last revised in 1968. So this new document, this is quite new. It was published this year by the government. It will come to use from March next year. The advantage of this is that it is more responsive to new materials. The older code was last revised in 1968. So from 1968 up to this period, there's been very major developments and changes in the construction industry. So it wasn't taking into account the new materials. People are now 3D printing homes, and now even the use of bamboo is coming up as well. So this code gives us that opportunity, and it also recognizes cultural or traditional buildings. So from the pictures there, the first picture is of a Maasai Manyatta. Manyata is a house that's the Maasai people, the house of the Maasai people is called a manyata, and it was traditionally built using sticks and then mud and cow dung, and that is how it looked like. The new code actually recognizes such buildings as long as they are built within the culture or the community within which they were originally found. I'm going to look at part 2, and I'll be looking at several projects that have been done across the country using bamboo. We have our first case, the Maseno University House. In 2009-2010, there was a project called Tobacco to Bamboo in a place called Migori. It was, I think, supported by IDRC and INBAR, being run by Professor Kibwage. And one of the projects that was brought or was done were 2 houses at Maseno University. And one of them was an engineered bamboo house. The second one is a non-engineered bamboo house. They're still there. And I think I can say that this is the first time that the discourse around bamboo took an academic angle, because these are not the first buildings of bamboo in the country, but this is the first time that they came to the academic arena. We have a community in Mount Elgon that has been using bamboo for the longest time, and they have evolved their their practices around bamboo over time. So this house is found in Maseno University, and the second one is also found there. This one is used as a student center or a student cafeteria. The third case I'm going to look at is called Anwa School. In Kenya, we have a slum called Kibera. Kibera is one of the largest slums around, maybe in Africa. So there's an organization called Konkwi Design Initiative that partnered with the mothers who founded Kibera, the Anwa School. A slum being a slum, an informal settlement, means that sometimes there's access to services like education could be hampered. So the mothers of the children around this area called Anwa came up with an idea of starting their own school. So when KDI or Concrete Design Initiative came on board, they found that the mothers were running the school, but not in a very safe environment. So they came in with a new design to help the mothers to build a new school for their children. This project was finished in 2017, and the main material used was in keeping with what the architecture of the slum area, which is wattle, daub, and mabati or iron sheets. So for the walling, this is what was the designers retained that detail of wattle, daub, and iron sheets, but they used bamboo for the windows and the doors. And they did this in collaboration with IFRI, which offered them technical assistance in terms of the training of, because they used this as an opportunity to train technicians on how to weave bamboo and how to work bamboo. So that is a picture of the installation process of the windows that are made using woven bamboo on the inside, and panels. The paneling is made out of timber. The second school is called Why Not Junior School. It's also found in a slum called Mathare. Mathare is also in Nairobi. The school was done by a group called Live in Slums. It's an NGO, and it was built from 2012 to 2015. They also did the weaving of the bamboo, and the paneling was done using timber, as you can see. The floors were done using concrete. But that's another example of a school done using bamboo in Nairobi. The other one is called Chungking Ebenezer School. It is also called found in Mathare. For this one, it was done by the Chinese people. And this one was a framed structure, it's framed in concrete. And then the infill is bamboo, let me just call them slats or poles, as you can see. And of course, there's also timber being used there. The windows were also encased in steel, as you can see, but the main structure is actually just concrete. You can see it on the surface here. This skills center Malite, the third case, is found in a county called Machakos. When I visited this was in 2019 that I took these photos. The Skills Center Mala offers vocational training in areas such as culinary and mechanical and electrical sciences. But of interest was the structure, the bamboo structure that they had. This was done in 2012 with support from the German government. So you can see tracing how it's done, and the doors were done using woven bamboo encased in steel. Although by this time they were falling apart. I haven't visited again to see how it is. But one of those projects that was very sensitive to the environment in terms of even the recycling of water. They were recycling all their waste. Even the human waste was being recycled through the urine diverting dry toilets, and this would be used now in food production. So it was very, very interesting. And then, of course, in a hot area, one of the most interesting thing was that between the roof and the ceiling, they had a layer of earth or mud to just help with the insulation to limit solar penetration. This is the case 8 is called Britam Tower. It's found in Upper Hill area of Nairobi. For this one, it's a new building, relatively new. I think maybe around 20, was maybe finished up in maybe around 2017, 2018. And most of the interior of this building is done using engineered bamboo. You can see this is the reception desk is done in bamboo. The wall paneling is bamboo. They had even done the using bamboo, and they actually up to the toilet doors and even the waste receptacles are done using bamboo. The only drawback to this is that the bamboo paneling was actually imported, informed from Malaysia. So it would have been a good opportunity for if it was sourced from within the country, but it's a good case for bamboo as well. There's another project called the Kefri Gazebo, Kenya Forestry Research Institute. There's a gazebo that has been done using bamboo. I'm proud to report that I was the architect on that project. The project was supported by INBAR and done at the Kefri offices in Karura Forest. The objective of this project was to train artisans on the utilization of bamboo in construction. At the design level, in consultation with the stakeholders, we opted for a curvilinear form so that we wanted to maximize the learning points because we didn't know how to carve bamboo and how to work with carved bamboo. The biggest challenges that we faced on this project was how to carve the bamboo, number one, and then the roofing of the structure was actually quite hectic for us. But we managed to come up with something. Those were the drawings. And that is the construction process. So we would do the bamboo off-site, like in a different location, then come with the rings and place them and fasten them in place. That is still the construction process. A different view of the process of construction. And then that is the roofing process. So initially from the drawings, we had actually wanted for the roof to be clear. We wanted a clear view to the sky. So we were proposing polycarbonate, which we soon found out was not going to work for this project. So we opted for something else. And what we opted for is maybe let me just call it a type of a ferrocement, where we were using Haitian cloth, this one, Haitian cloth. And we immersed the Haitian cloth in cement slurry, and now just came and put it up over the structure. But then for us to have to just ensure that we will not have leakages, we had 3 layers on the roof on the bamboo structure. So the first layer was the first layer of Haitian over the bamboo structure. From the Haitian, we encased the whole structure in a polythene, paper. And then just to ensure that we would not have any leakages, and then now we came and put the Haitian and cement on top of that. And so that is the outcome or the process of construction. That was the final outcome. I've also been involved in, with support from KEFRI, the development of the bamboo parquet, which the vision of the project is that it can compete actively with timber parquet on the market. The only drawback to this when you compare it with timber parquet is that for timber parquet, the sellers actually, it's normally like, it's a byproduct of other things. So they've done their frames and cut their wood to whatever they need. So the offcuts are then now fashioned into parquet. So comparatively, the price of bamboo parquet is higher, because then bamboo parquet is the main product and timber parquet is most often the byproduct of other processes. We're just experimenting as well at Mianzi and under KEFRI's guidance on now different stains of doing bamboo engineering, using coming up with floorboards. We soon found out that we can't use the conventional stains on the market that are used to stain wood or timber. We experimented with mahogany, I think teak, and something else. But the finding is that we found that the beautiful grain of bamboo disappeared when you put other stains on them. So we have since learned that the clear varnish on bamboo is the best option at this point. But this is just still part of the experimentation process. And even the last picture shows a flame treatment. We were trying to do flame treatment to see what tonal variations we could achieve in terms of color. This is a project by, these are products being done by a company called Tiriki Bamboo. I'm not sure whether they still go by that name, but these are the products. Here they're experimenting. These are cornices for the first and the second image. And the image is interlocking floorboards. So there's also another project that has been very interesting, the Bamboo Dome. This is an exploration project to build a geodesic dome using bamboo. This project was done by Bamboo Art and Design Studio. It is aimed at exploring the potential of bamboo in terms of its lightweight and strength and durability. It's also aimed to showcase structural efficiency and simplicity. So the primary materials used for this project are UPVC, plumbing pipes, and bamboo. So the first picture shows that project, and in this it was being used as a display in a trade fair, and it actually generated a lot of buzz and a lot of people really spoke about it. So it was good to showcase that project just to give bamboo the visibility that it deserves. The second piece is shows the construction process. The gray being the UPVC flattened at the end so that they come together and join to create the connectivity in that manner. So we have also had opportunities, or we have emerging opportunities for the use of bamboo in the construction industry in Kenya. So I'll also briefly go through this. Case one is the Safe Learning Post-COVID project. Proposed guidelines for the safe reopening of schools post-COVID. So during COVID, the Association of Architecture, there's an association called the Architectural Association of Kenya, which comprises not only of architects, but other professionals in the built environment, engineers, quantity surveyors, planners, and the like. So they proposed a task force that was to look at reopening of schools, the safe reopening of schools. If you remember that time, there was a lot of school closure. And then we were in the era of social distancing and masking and, washing your hands and sanitizing. So this project was supposed to just look at various typologies that could be advanced as ideas for the government to look at the post-COVID school. The task force comprised of volunteer professionals with diverse backgrounds. The goal was to address school safety necessitated by COVID-19. Various typologies were advanced. I'm happy to report that I was part of that task force. And of course, I spoke for bamboo. And so we had a model classroom design to be built using bamboo. That work can be accessed at that point on that website. So that is the plan of the proposed classroom. Remember, the spacing was supposed to do a lot of spacing. The spacing was it 1.5, 1 meter, 1.5. It was quite huge. And then there was to be a lot of airflow and air circulation and washing points for when you're getting into the classroom and separate entryways. So we had 2 door points and windows, very many windows, a lot of air circulation, as you can see in this image. You can see we had all these windows on this level, and we had high level windows as well. We even had wind cutters on the roof. So yeah, that was the proposal that we came up with for the COVID classroom. Still just part of that, the details of that. The second project that I want to talk about under that, is emergency rescue center called Kanyagwar Emergency Center. Kanyagwar is located in county called Kisumu, an area called Kano. Kano experiences flooding mostly during the rainy seasons, not all the seasons, but in most seasons. The interesting thing about the flooding that happens in Kano is that the water comes from a different place. So it's not the rain that falls in that place, but the water comes from a different place called the Nandi Hills. And the water flows through Kanyagwar Kano area, as it flows towards there's a lake called Lake Victoria. So the flooding is very severe because this is a relatively flat area with clay soils or black cotton soils. The interventions that people get during these times is that they get tents. The Red Cross offers them tents. And the tents are actually not ideal because they're usually, the area is quite hot. So when you have a tent that doesn't have a window, because this is a plastic sheet over the structure, it tends to get very hot during the day, and then it's actually not safe. There's no permanence to it, no safety, no nothing. So the objective of this project was to promote better emergency housing using bamboo. We also had the objective of training local artisans on the use of bamboo and also encourage bamboo propagation in that area, because the argument was that in the areas where there was plantation, the floods were less severe in that area. So the brief for the design included an infirmary, an administration block, men's hostel, a ladies' hostel, and then a silo for food production. And the rationale behind the silo was that when the water comes down from the hills, it comes with very rich alluvial soils. So then after the floods, the farmers get very good harvest. They plant rice and I think beans and maize. So they get very, very good harvest after the floods. So then we needed, the proponents wanted a situation where the excess food can be stored for emergency, times of emergency. And then there was also a proposal for a solar farm and a weather station to do remote monitoring of the weather in that area. So the proposed built area was 880 meters squared. And part of the brief was that we were supposed to house 50 to 100 people. Through our proposal, we achieved 72, which was a good thing. That is how the project was proposed to look like. So here we can see number one is where there's an infirmary. And the importance of the infirmary is that during such events, adverse events such as the floods, people may not be able to go to hospital to get care. So they needed something that would be close to the community where people can get medical attention. And then number two is the men's hostel. Number three was the ablution block. So we decided to center the ablution block because, in a situation such as a flooding area, the waste management aspect is very, very critical because there's a lot of pollution, especially when it comes to human waste management. And this area sits right next to the lake. So then the people there use pit latrines. And when it rains and it floods heavily, all this waste mixes up with the water and they end up in the ocean and in the environment. So we wanted a situation where we could centralize the waste aspect, human waste aspect, and find a good intervention for it. Number four is the ladies' hostel. And number five was the administration block. The two cylindrical objects was where we're supposed to have the silos for food storage. And then at this point, we would have the weather station. This is just the plan of everything, so I will not go into the detail of it. So what it would look like, the infirmary at that point, the admin block. So we experimented, or we were looking at using bamboo with several other materials. Several challenges that were experienced on this project. We had environmental factors as challenges. The project needed to be sited at a location that was deemed a bit high, topographically a bit raised, because the area is flat, majorly, so they needed to find a place which was a bit raised. And this was hard because there are only a few points within the locality that are a bit raised. And then whoever was owned the land in that raised place would then be compelled to, maybe donate the land for communal use. Geotechnical aspects, because the area is mainly clay, the soil is clay or black cotton soil, and the stable ground is, I don't know, I think you'd have to do a lot of excavation to get to any farm ground. So we had an able engineer on the project who advised us on what to do around there. Political factors, the locals had to embrace the project, and the land acquisition, as I've alluded to, was also another technical aspect because we actually ended up going through, I think, 3 different sites. So we started work on site 1. The county government of Kisumu and the local community and the donor, the land donor, didn't agree. We went, I think, to the 2nd site and ended up on a 3rd site. So because it was quite challenging. Social factors, as I've mentioned, human waste management was quite a laborious task for us. So the first intervention that we were proposing for that was the urine diverting dry toilet, which the community did not accept. And they said they were not comfortable with such an intervention. So eventually we ended up with we proposed a raised biodigester to sort out the human waste management aspect. And then economic factors, the budget was limited. The budget was being funded by an organization called Adrelo, working with the University of Nairobi. Because of the delays on the project, we were not able to go to site. So the county government has undertaken to do the project because the funds were recalled, but of course now not using bamboo as the main material, because we wanted to use bamboo as the main material just to showcase the material, how we can use it. That is borrowing from the annual school and the other people who are doing weaving. We were proposing woven wall panels in some areas, especially the hostel area. And so we would have the woven element on the outside, and on the inside we would have the flattened bamboo, as you can see in that video at that point. Yes. That is just a different view, the view from the ablation block. So other just experimental projects, landscaping and garden furniture. These were proposals. Actually, this was part of the proposal for the Kefri gazebo, but we ended up with what we did. The same. This one, just to showcase the kind of opportunity that we have. There's a QS that reached out to me, a quantity surveyor. They wanted to have their building, this particular building, clad in bamboo at the top level. So this image is just to encourage us that there's actually hope. We're going somewhere. They didn't get back. Maybe the price was a bit too high, I don't know, but this is just to encourage us that, yeah, people are looking and seeing what we're doing with bamboo. So I'm going to look at the barriers to the use of bamboo for construction in Kenya briefly, more at the end now. We have issues around cultural views and biases. Different communities have different views for or against bamboo. And Kenya has quite many communities. We are over 42, I think. So different beliefs. There are those who believe if you plant bamboo, you'll die. If you plant bamboo, you're maybe a witch because it attracts snakes and the like. So there's a need for awareness creation to counter these views. And of course, people think that bamboo is not strong. You know, when you look at it, you just think it's a very weak material. So need for awareness creation, more aggressive awareness creation. Knowledge and information deficit, and especially I would talk about the professionals in the built environment. We don't have a lot of this.
Sylvia, we'll appreciate if you wrap up a bit with time constraint. Thank you. Okay, fine. So yeah, limited technical know-how, we need more training, and then limited design standards, more research. The future, landscaping, these are some of the areas where we can apply bamboo going forward.
landscaping, features such as gazebos. We feel that gazebos and pergolas would be a good showcase, start small and go bigger. So flooring materials, scaffolding, which is a major area that we can tap into so that we can save our trees, especially looking at things like solid bamboo. And then we've had a team, EcoGreen, exploring with bamboo slabs and manhole covers, as you can see there. So this is something that needs to be researched further and using whatever professionals we have. And that will be the end of my presentation. Thank you very much.
Sylvia, thank you very much for a very nice and detailed presentation. So at this level, I'll pass on to my colleague, Professor Dinamo, to continue with the facilitation. Professor, over to you.
Yeah, thank you, Rene. It looks like we are running out of time, so I would right away go to the questions we have, and I would kindly ask all the three presenters to be very concise in responding to the questions. First, I would like to appreciate, those all three presentations that we had, from Emmanuel to Paulino and finally to Sylvia. So they were very interesting presentations, more or less representing the different regions of Africa, from west to Emmanuel, from the west, Sylvia to the east, and we had also one from the south. So I think we'll be having only one round of Q&A. I have tried to capture the questions sent to us via chat. So I will mention names and the respective questions, and if I missed anything, maybe you can help me. Otherwise, I will proceed. So questions to Emmanuel. The first question was from Robin Mida. So I hope the presenters would jot down their respective questions. So the first question to Emmanuel is, can I know how the bamboo lime brick is made in the city area built? So Rowan would be happy to visit the project, so maybe you'll note that as well. Another question from Fred. He had, I think, a couple of questions. Could you give me more insights on how biochar can be manipulated into useful construction material, or kind of converted to useful construction material? The other question is, what is your experience of clay lime performance in any of your projects? So what is the mix ratio of the material? And is the clay in a dry form before mixing with lime? So these two are kind of technical questions, so you can briefly respond. There was also another question from Henry Simo. I hope Rena would help me with this language. I think it's in French. So a question from Henry Simo. Another question from, okay, maybe you'll interject or you'll jump in, Rene, so or would you like to okay, please go ahead. No. Go ahead, Rene.
Okay, thank you. So Henry Simo was asking that the building of this school is done with which species of bamboo? But I don't know to whom the question is directed to. I don't know if it's Sylvia or if it's Emmanuel. Maybe both can give their views.
Sure. The other question is from Henry Kawando Boiteng. So this is directed to Emmanuel. Is there any standards in Ghana for the use of bamboo as reinforcement in concrete? Is there going to be vertical buildings? I think this refers to multi-story buildings, if I understood it correctly, in the bamboo eco-city. If yes, what materials are you going to use for the structural framework or the structural system? Yeah, okay. Okay, this question goes to, I think, Paulino. So the question goes like that. I am from Canada, but my question is regarding tropic areas with mangroves. Did you guys study the inter-effect of bamboos versus mangroves? Okay, so I think this is the only question Paulino has. So when it goes to, or when we go to,
Dr. Demani, are you there? Or have we lost
Yes.
you?
No, I'm here. I thought Dinamo was still listening to the questions.
Yeah, but I think he might have had a connection issue.
All
So
right,
I'll
so
step
then
in.
I
Yeah,
can
so
continue.
maybe I'll give first the floor to Emmanuel, and then to Paulino, and then to Sylvia. Emmanuel, over to you for the questions that you've jotted down.
All right, thank you very much. The first one was on the lime bricks as to how it's made. We have conducted our research, and there are different types of laterites and clay deposits. So for every clay type with this moisture content, we have the percentage of lime we add, ranging all the way from about 2% to 8% of the material that we use. And we have the optimum moisture content. They are not mixed wet, they are mixed dry. So just as we do concrete blocks, using cement to sand in that ratio, for emphasis, we also have this addition, and there's no wet. So take note, there's no wet. It's mixed just as we do normal sand cement, but we have an optimum moisture content we use for the lime bricks. And then is the city built? The city is not built. We have the land preparations ongoing, all the materials tested, machines. Some are already fabricated. For instance, the brick machines are available. We are building bricks. They are prototype houses, but the city is not complete. So if you want to visit, you come later on. And that is why we are calling for more investment, because like real estate, you need investors to buy into these housing schemes. You don't just build them there without ownership. So we call on all who support sustainability and these smart ecological cities to come on board to invest in the city. And then with biochar use, biochar is just like activated charcoal. You know charcoal, that's what we do. We are using the bamboo. Once we char it under pyrolysis, you get biochar. So it's also in the form of aggregate, fine aggregate, which is used in the mixes as we use lime. But the biochar has these properties of becoming insulating and also absorbent. It takes odor, it takes moisture. It doesn't make the room humid, and so prevents any poor indoor air quality. It makes it ideal and also cools the environment within the housing system so that you don't rely so much on energy powered by air conditions within this hot, humid climate. That's how we make biochar. The clay lime performance, we realize that the clay lime bricks strength from the start is not as defined bent clay. However, with time, as it stays in the environment, it increases in strength. So we still have materials in our laboratories we are testing over the years, and we've seen the improvement in strength, which doesn't happen with normal cement, concrete, and mortar bricks. Why? Because the cement hydration process is completed, and by 28 days, it attains its maximum strength. But the lime continues to increase in strength in the mix with time. That is one thing we have found out about this claim lime. So that's the performance with it one. And as I said, it's not mixed wet, it's mixed dry. For Engineer Boating's questions, there was a question also on the which species of bamboo is used for the housing. Ghana, we have predominantly the Bambusa vulgaris, and then the bamboos of Garris vittata. So these two combinations are what we're using. But the challenge is that they are not straight columns. And so the exotic ones, like the Guadua chacuensis available that we use to augment these, where you need straight poles that fit into this brick with a hole in them. The standards in the use of bamboo. In Ghana, we don't have standards yet. We don't have standards for the use of the bamboo as reinforcement. That was a question in concrete. We don't have standards yet. And so there are a lot of evolution of this use of split bamboo in concrete. With the bamboo's property of good tensile properties, it is very possible it can be utilized. We still have research ongoing where we're trying to increase the bonding between the raw bamboo and the concrete mix. So currently, no standard yet, but there's a lot of research work ongoing. And I'm sure the task force on bamboo will be working on these things, and definitely there'll be a global ISO standardization on going for the use of bamboo. And then I think there was also a question of, is the buildings going vertical? Yes, the building, we have some buildings in some of the high income areas going vertical. And what material is going to use for the structural frame? The structural frame, we're still using bamboo for the columns. We're using bamboo for beams support, and then also we have the decking made of combination of bamboo boards that are available. It will marvel you if you have bamboo floors that have been made into deck. We have a product called bamboo scrimber. Bamboo scrimber is much stronger than even concrete beams, and it competes with steel eye sections and can withstand any floor loading that can be utilized even without noise. And all these have been tested in some of our labs in China, and they are doing fantastic. So they can be utilized for to be using those for the high rise, for the high income areas where these products, because they are engineered bamboo products, the cost is much higher than the raw bamboo cones that we utilize. Right? Is there any further questions for me? Well, I guess I've done justice to the questions.
Yeah,
Thank you
I
very
think
much.
in the interest of time, yeah, sorry.
Manu, over to you. We lost you for a
Yes.
while. Over to you.
Yes, I was disconnected. Sorry, Rene. So I think in the interest of time, we should proceed to Paulino and then to Sylvia. And just briefly, please respond. We are already running out of time. Paulino, then Sylvia.
Thank you for the question. Although I don't know if I understood well the question raised up. Well, for what I understood is that we've been studying some bamboo species that can be cultivated in salinity soil, not exactly where the mangrove grows, but where the salinity soil is present. And those species include Strictus, Tulda vulgaris, the two variants, Vulgaris vittata and Vulgaris common, the green one. But we're also aiming to introduce Balcoa and Bambusa bamboos and some other few species just to see how it will behave on salinity soil. But it's a fact that Vittata, at least, is really growing well on soil salinity. And we have the example of one island where it does have salinity problems. I don't know if I answer your question. Please just inbox me if it's not if you're not happy with the question, so I can go back to you because I didn't really understand 100% what do you mean by your question. Thank you.
Yeah. Okay, let's proceed to Sylvia. So.
Okay, I missed the translation from French to English, but on the chat, the questions that came through, there's the one that has been answered on the chat. Someone had asked Devonport why the land had reduced from 2/3, by 2/3 the land area under bamboo. That has been answered on the chat. The other question
Sorry,
is
Sylvia, there was another question, like
which
why is the deficit of 10.3 million meter cube?
Yes.
Again, divided into demand, supply and deficit. Maybe, yeah, that's towards you. Yeah.
Yeah. I don't think is the same figure. I will confirm if it's the same one. I'll correct on the presentation, but I think they're two different figures. Because one refers to the timber required in the construction industry, the other one is a deficit. Thank you.
Yeah, thank you. Thank you so much, all the three presenters. I mean, I would have loved to continue discussing, but I think at the time there is time constraint. So, but I would strongly suggest that you continue the conversation. So I hope the addresses of the participants might be with INBAR. So if you have any questions, you can direct those questions, and I think INBAR would facilitate further discussions. So, I mean, I can see Durai, so I'm happy to see you, Durai, after a while. So without further ado, I will give the floor to Durai, and thank you for your attention.
Thank you very much, Inamo. I think am I audible? My sound is clear?
Yes.
Yes, I can hear you. I
Great.
confirm.
Thank you very much. I think in the past three some sessions we had like a very interesting presentations on the bamboo construction. As we all know, and as we have been discussing here, that bamboo is a very important construction material in Africa, as in the other parts of the world, be it in Asia, be it Latin America, be it Americas, and even the EU. But traditionally, the bamboo construction has been a very important aspect in the African continent as a whole, starting from some Madagascar to Ethiopia, and at the same time, so it is widely available in all the parts of the continent, be it southern, eastern Africa, and at the same time some western and in some central Africa. So bamboo has been a very important some construction material. And in the three sessions which we had on the innovative technologies, codes, enterprises, and the environmental impacts of the bamboo construction, we have seen the recent development of the bamboo construction in Africa. So in the past 10 years or so, there has been efforts on the bamboo construction across the African continent. Though the true potential of the bamboo has been reached. So when it comes to construction, as with other construction material, there is still a large gap to be addressed. And we see a huge potential, and we see a huge interest coming up. This session is years some webinar focused on the bamboo construction, particularly from Africa. We had the speakers mainly from the African continent or the project which had been undertaken in the African continent. And we had around some 600 participants across the world. Participants both from Africa and the global participants have participated, which shows the interest of the bamboo construction. Thirdly, we want to appreciate the knowledge shared by the speakers from different countries. Though in the current session, we had Professor Kubi, I think, and Paulino, and we have also seen some Sylvia presenting a very great amount of some work which they have been accomplishing in the recent past in their respective some countries. And in addition to that, we had also Dr. Inamo, who has done a great amount of the work in the bamboo construction, particularly in Africa. And we thank all of them for their a great effort. And fourthly, we want to appreciate the task force, like some members who had like some supported the organizing of the webinar and also like some moderated the sessions and also delivered the presentation. Today, the session was like moderated by our colleague like Rattan. We thank him for his support and we thank him for like some moderating of the session and also to coordinate the speakers to be present in the session. And finally, we want to thank all the INBAR colleagues, like particularly from the HQ, like Kuwai, who has been the organizer of the bamboo construction seminars for the past like 4 years, from the COVID time up to now. Though we have stopped all the webinars, we still continue to do the construction webinar, like some because of the interest and like some participation from across the world. In addition to Kuwai, we also thank Chengwai, and she is our like some backend, like some supporters who coordinate the IT arrangement along with Mr. Kuo Yu-chen, our IT professional who is in our HQ. And in addition, we thank the colleagues from the African regional offices like Biru Kebede from the East Africa, like some Michael Kwaku, like some from like some West Africa, and Anne come from the Central African regional office. And finally, I want to thank our intern Zipai, who has been like some coordinating all with the speakers and at the same time coordinating with the participants of the session. With that, I want to thank like some most importantly the audience who has been like some supporting us to continue with this like some webinar. With this, I thank you all and I thank you to have a good day and like some good evening and like some good night to the people from different parts of the world. Thank you very much.
Thank you very much, Durai. Before we close the session, I will kindly request that we have a group picture to document this session. So I will invite, for those appropriate, without any cause of inconvenience, to kindly switch on your videos so that we can have a screenshot of all the participants. And I will request Chinghui to do the screenshot for us.
Okay. Sorry. Okay, everybody, please open your camera and wait a second and we'll do the screenshot.
Can you authorize the opening of the cameras? Some of us cannot open it from our end.
Kwako, you can open the camera.
You click it and say that the host has stopped it.
No, nobody is stopping you from your showing your camera. You want to see your beautiful face.
No, I'm here.
No. It's not opening. Actually, it's even to my side.
I see.
Okay.
因为你让玉成给他们权限一下，打开这些视频。
打开了已经，我这个没有摄像头。
他们为什么打不开自己的摄像头呢？
哎，看看啊。
Okay.
他们可以打开，可以打开。
Good.
Okay.
Not yet done. It's still not opening.
Yeah, the group photo is down.
Okay. Thank you very much. Nelly, I like your smile.
And Ellie is there. Ellie, how are you?
I'm very fine, Durai. It's good to see you.
Sorry, I don't like some see you.
No worries.
Good. Happy
to see
to
you.
see you.
Yes, good to see you all. Thank you so much for the information and sharing.
Thank you.
Yeah, let's move Bamboo forward.
So why? Thank you very much for you. So it is all for you. So you organize the construction seminar for like one more year.
Yes,
it's my great pleasure, and I hope we could see you the next year.
Good.
Sure.
Awesome.
Good.
Thank you very much, Paulina, for accepting the invitation, and all speakers invited. Thank you all for Africa. Professor Koptik, we thank you all.
Thank you. Yeah. It was great seminar. Thank you for the organizers. It was great. Thank you.
Yeah.
Thank you.
So we apologize for the very short Q&A session, but please don't hesitate to send your questions, and we'll be able to coordinate with the speakers.
That would be nice of you, Rene. Yeah.
Okay.
Thank you very much.
Very much.
Bye-bye
thank
to
you
everyone.
too for the opportunity.
Bye-bye.
Thank you.
Thanks, Rene.
Okay.
Thank you, sir.
Bye-bye.
Bye-bye. See you next year.
See you next year.
Yeah.